Hey gang, welcome back. So we've been talking about some of the basic rules of probability. And today we're going to talk about something called the addition rule. Now this is one of the, I'd say, two most fundamental rules in all of probability, and it's really rather straightforward, kind of like addition. And here's how it works. Uh, you might be asked, what's the probability of X or Y happening, or A or B? Right? So two contingencies or more. It could be like, what is the probability of A or B or C or whatever happening? The critical word there is or. And we'll need to consider a couple of contingencies, whether X and Y can both happen or at the same time, or whether they can't. So we'll be looking at questions like, what's the probability that you, one, win the lotto, or two, marry rich? And then I guess you'd want to know, well, what's the probability of, like, can I do both? Can I win the lotto and marry rich? Right? So there'll be two slight variations depending on whether you could have both of those things. So, so that brings us to the idea of a mutually exclusive event. Right? So two events exclude each other if they can't both occupy the same space. Right? Like if you and your ex-girlfriend cannot be in the same room, then her being in the room excludes you from being in the room. And likewise, two events. If they can't happen at the same time, then they are mutually exclusive. They exclude each other. So we really need to know then, can you have both things? Can you have win the lotto and marry rich? So let's do an example. Let's say that you draw one card and you want to know what's the probability that it's a heart or that it's a diamond. So we got two outcomes here, hearts, diamonds. Can that one card be a heart and a diamond? No. So if you draw a heart, you know it's not a diamond. They are mutually exclusive. What about these two events? You pick a card and it's an ace or it's a diamond. Can both of those two things happen at the same time? Can you have the ace of diamonds? Yes, there is a card called the ace of diamonds. So those two events are not mutually exclusive. And what we'll see is that there's going to be two variations on the addition rule. One for mutually exclusive rule outcomes and one for non-mutually exclusive outcomes. All right. Last example for mutual exclusivity. You pick a person at random. Outcome A, she works less than 40 hours a week. Outcome B, she works more than 40 hours a week. Are these two events mutually exclusive? Yeah. She either works less than 40 or she works more than 40. Incidentally, this list here is not exhaustive. She could work exactly 40 hours. The fact that it's not an exhaustive list of all the possible outcomes is immaterial here. All we want to know is, if I'm asking what's the probability of A or B, I need to know whether you can have A and B at the same time. So how do we use this addition rule? What is it? So let's say you got a whole bunch of different events, not just two of them. You could have N, whatever N is. If they're mutually exclusive of each other, then what's the probability that you'll have A or B or C? Like, what's the probability that at least one of those things will happen? Well, then all we need to do is simply add up each of the individual probabilities. So it would be probability of win the lotto. Well, actually, that one's not mutually exclusive. So it would be the probability of A1 plus the probability of A2 plus the probability of A3 and so forth. So let's see this in action. You roll a fair-sided dice. What's the probability that you roll a 1 or a 2? Okay, now the outcomes 1 and 2, they're mutually exclusive. You can't roll a single dice and have it come up 1 and 2. So since they're mutually exclusive, we can use what we're going to call addition rule number 1, our simple addition rule, which is to just add up the probabilities. So let's see how this works. The probability of 1 or a 2 is equal to the probability of 1 plus the probability of 2. So what's the probability of 1? Well, we got a 6-sided die, so it's 1 in 6 chance it comes up a 1 plus a 1 in 6 chance it comes up 2. So the probability of 1 or 2 is now 2/6, or about 1/3 or 33%. Easy, right? Okay, another example. You select a card from a deck of 52 cards, a standard poker deck. What's the probability that it's a king or a queen? We need to ask ourselves, are those two outcomes mutually exclusive? Can you have a king-queen? No, not in poker. So what's the probability of a king or a queen? Just add up the individual probabilities, right? So probability of a king or a queen is the probability of a king plus the probability of a queen. So what is the probability of a king? Well, there are 4 kings in a deck of 52. There are 4 queens in a deck of 52. That gives us 8 out of 52, which is around 16%. Easy, I'm telling you. Okay, another example. You had a student council meeting. There are a handful of people. I see 16 people. 5 freshmen, 6 sophomores, 3 juniors, 2 seniors. So 16 people. And you draw lots, and one of those folks gets the privilege, the honor of having to take notes, meeting notes. What's the probability that that person will be a sophomore or a junior? Well, can you be a sophomore junior? You can't be both at the same time. You're either a sophomore or a junior. So what's the probability that you'd pick a sophomore or a junior? Let's use our addition rule. We've got 6 sophomores out of 16 people, and we've got 3 juniors out of 16 people. So the probability of sophomore or junior is 9/16. Straightforward. You select a card from a standard deck. What's the probability that it's a king or that it's a diamond? Well, are kings and diamonds mutually exclusive events? Can you be both? This time, yeah, you can. They are not mutually exclusive. You can have the king of diamonds. So addition rule number 1 is not going to work for us anymore. Now there is a different addition rule that we can use. Addition rule number 2, if you want. Let's see how it works. So here's a visual explanation of addition rule number 2. It's kind of a Venn diagram. And so this larger blue box could be the total probability space. And then we've got event A. We've got event B. There's a little bit of an area of overlap. That part is, I'll come back to that part. But the question is, what is the probability of A or B? So in other words, I'm interested in this probability. What fraction of that big square is this peanut looking shape? Right? So the area inside the peanut as a fraction of the blue box area. That would be a visual representation of the probability of either one of these two things happening. Now, what if we use our addition rule number 1? Then we would take the probability of A, and then we'd add the probability of B. And so what would happen is this area here, this probability of A and B, would get counted twice. And so, well, we shouldn't do that. So let's take one of those out. So that's what happens here. Right? So in this scenario where you can have A and B happening at the same time, they're not mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B, and then take out one of those areas of overlap. Right? Here is a cleaner version of that same thing. Take the probability of A. Notice it includes that area of overlap once, but that's okay. It's allowed to be in there once. And now what we want is to add to that this, not including A and B a second time. So if we were to just add probability of B, that would include this guy a second time. So let's take him out. Hence, why we subtract him out. Okay, so that's our addition rule number 2. And it's easy to use. Just like the first one, there's only one extra step. It's subtraction, but you can handle it. So here's another example. You roll a dice. What's the probability of getting an even number, so that's event A, or a number less than 4? Okay, now notice, you roll a dice. Can it be an even number less than 4? Yeah, it could be a 2. Right, so they're not mutually exclusive. We need to use addition rule number 2 now. Okay, so how do we do that? Well, it's right there in front of you. Probability of event A, which was an even number, or a number less than 4 is the probability of evens plus the probability of a number less than 4 minus, well, what's an even number less than 4? It's 2. So minus the probability of a 2. All right, so how many evens are there in a dice? There's 2, 4, 6. So 3 out of the 6. How many numbers less than 4 do we have? We got 1, 2, and 3. Not less than or equal to 4, just less than 4. So 1, 2, and 3, that's 3 out of 6. And then the 2 out of the 6. So 3, 6 plus 3, 6. Well, gosh, that would give you 6, 6. That'd give you 100%. You know that's not the case. Hence reminding you that you should subtract something. So 6 6 minus 1 6 gives you your 5 6. Then that's your probability. All right, let's do another example. Okay, so let's say you select a card from a deck of 52. What's the probability that you get a face card or a spade? And here I'm not calling aces face cards. Faces are jacks, queens, and kings. So can you get a face card that's a spade? Yeah, you can get the jack of spades, the queen of spades, the king of spades. There's a bunch of those, that area of overlap. So we'll use addition rule number 2 because we have events that are not mutually exclusive. So what's the probability of a face card? Now, well, how many faces do we have in a deck of 52? We got jacks, kings, and queens. We got 3 of those, but we've got 4 different suits. We got diamonds, hearts, spades, and clubs. So there are 12. Oops. So 12 out of 52. How many spades do we have? Well, we've got 10, so ace, and then 2 3s. We got 10, plus the jack is 11, queen is 12, king is 13. Minus, how many spades do we have that are faces? We've got 3 of those. Right, we got the jack of spades, the queen of spades, and the king of spades. So we have 22 out of 52, which is approximately equal to 44%. Let's do another one. So at this point, I really should mention There really is only one addition rule. It's not like you have to memorize two different ones. I find it useful, at least at first. But really, there's one addition rule. It's the complicated one. It's the one where you got to subtract out something. Right? And then as you're plugging in values, probability of a face, probability of a diamond, and then, well, if you have face of, a king of diamonds or whatever it was, then put that in there. But if the two events are mutually exclusive, then there's no chance that you could get A and B. And so you would just plug in a 0 in here, and that would leave you with addition rule number 1. So in other words, addition rule number 1 is just a special case of addition rule number 2. If you need just cram a whole lot of stuff into that index card for your exam, just put that one big addition rule, and then you can just plug in zeros as needed. Thanks for listening.